Sunday greetings to all my good folks at RMC. This is Kami coming to a theater near you. Yes, we saved the best chemical warfare detection technology for the last. So let's begin. We're going to talk about GC-MS. And that's a combination of instruments, namely gas chromatograph and mass spectrometry. This combination provides 100% foolproof identification of all chemical warfare agents, but at incredible low concentrations. It means it has the best detection limit. A special CBRN units in Canadian Forces Base Trenton carry very sophisticated, up-to-date, and portable GC-MS instrumentation. And I'm proud to say that I taught the senior officers in charge there. So let's look at this incredible combination, and we're going to start with GC, or gas chromatograph. The primary function of GC is to separate different chemical compounds from each other. Why is this important? Because in many instances, more than usual, chemical warfare agents are mixed with other chemicals. Simple or complicated, but it's a mixture. And in order to positively identify the chemical warfare agents, we must separate them first. So we're going to separate the good, the bad, and the ugly. So I have prepared a kind of a demonstration for you. I'm just going to dial it up right now so we can actually see this in very simplified form. So you can see here are the workings of a gas chromatograph and a combination of chemicals. The green, the red, and the yellow are sucked in. And you can actually see the red, let's call it the good, separates first. The green, say the bad, separates second. And the yellow, the ugly, the chemical warfare agent separates last. So if you look at this again, they go to a filter first, they go to a separation column. Based on their masses and polarity, they get separated. So red comes first and a red signal. Then green comes second, meaning probably it's heavier or more polar. It comes second as a green signal. And last, the yellow, or our ugly chemical warfare agent, it's heavier and more polar and appears as a yellow signal. So now permit me to stop this and go back to my presentation in here, and you will see in here that after what we showed, you can actually see a typical gas chromatogram chart, and you can see here this peak appearing at 3.67 minute, belonging to, yes, GB, Saurin, and that is preceded by two other chemical compounds that we call them the good and the bad, Saurin being the ugly. Now, after the separation has taken place, Saurin showing up at 3.67 minute, we have to positively identify Sorin. Yes, we have separated now. Now we want to identify. So now that signal or separated Sorin is sent on to mass spectrometer. And as the name implies, it's going to find out the mass of that signal at 3.67 minutes. How does that work? And you can see from the lower left-hand side, the signal arrives, or that separated Sorin or ugly guy appears from gas chromatograph inside a vacuum chamber of mass spectrometer. And what mass spectrometer does, it subjects the Sorin molecule to a burst of electron machine gun. It machine guns the molecule of Sorin, or the molecules of Sorin. That machine gunning action breaks up the molecule of Sorin, and that breakup happens in a very, very distinct way. That breakup is distinct for every molecule. Sorin's breakup is different than any other molecule. And to demonstrate that breakup, we're going to look at Sorin in here, molecular weight, and that's the molecular structure of Sorin. So when our machine gun, electron machine gun in the mass spectrometer goes into action, this is how Sorin breaks up. The molecular weight of Sorin being 141, it breaks up to a fragment that has the molecular weight of 99, as you can see on the screen. Now, that 99 appears on a mass spectrometer chart as such, and you can actually see the middle peak appearing at mass 99, indicating that the fragment that weighed 99 that was separated from Sorin molecule in that machine gun action. To the left and right of that 99, other fragments of Sorin appear at 81 and 125 respectively. And that is how we can identify Sorin at incredibly low concentration. Now, to finish off the chemical detector agents, we have what's called selection factors. In other words, when as a senior officer, you have to make decisions. How much money do I have, and what's best for the troops, and how do I invest my financial resources well? Well, the first thing that comes in is the unit cost. How much does it cost? Yes, GCMS is the best, but it is not cheap. Chemical agents detected? Yes, GCMS got you all covered. Sensitivity? GCMS, absolutely the best. Resistance to interference? Not really. Why? Because GC separates different chemicals from each other. So there is no interfering of one chemical to the other. So yes, you can say, well, that's what I'm going to buy, even if it's expensive. But here's another angle for you. Response time. The GCMS response time is respectable, but it's not as fast as ionization detectors or flame photometry. So that's another consideration, which I have to have a kind of a 1-2 combination to cover my bases. Best detection limit, resistance to interference, sensitivity, nothing beats GCMS. For response time, I need the ionization detectors and flame photometry. And there are many other factors in detection states, like vapor and aerosol and liquid, and portability. Yes, all of these things are portable, and I have mentioned that. And operational environment, really all of them are multi environment, have capabilities, durability, no doubt. But another thing is for operator skill level and training requirements, I could argue that GCMS requires a more educated operator and technician, whereas ionization detectors and flame photometry, they are basically standalone, and they are primary alarms, and life is good. So you will come to a point that you have to buy a combination of these chemical detector agents in order to satisfy all your needs: low detection limits, response times, portability, operational skills, and so on. This is the end of chemical warfare detection section, and we will start a new section next time I will visit you in your shacks. Thank you very much, and stay strong.